Today we are going to focus on the introduction to complex numbers. So one thing I want you guys to understand and know is that by the end of this topic, we should be able to answer these questions. Okay. So if we will be able to answer these questions by the end of this topic, it will be easy for us now. Then we are going to explore different questions from past papers. We see how we can solve them. So by the end of today's class, we'll be able to solve all the questions from question 1, okay, and question 2. Okay. So without wasting much of your time, I think we can start. So this tutorial sheet has got a lot of questions, actually, different questions. So it covers almost all the concept of complex numbers. And the good part is I solved this tutorial sheet and I uploaded the video on YouTube and on website, so you can access it if you want to know more about complex numbers before we even learn. So let's begin our discussion with complex numbers. So what is really a complex number? Okay, so a complex number, it is a number which has got two parts. It has got what we call the real part and the imaginary part. Perhaps you have seen something like this: a plus ib, or some other people will say is a plus bi, which is basically the same thing. So this is a complex number. So a complex number, it is in the form of a plus ib, or you can say a plus bi, where a is a real number. This is a real number and this is the imaginary number. Okay, so this is the imaginary number. Now one thing I want you guys to understand from here is whenever you see a number which doesn't have I and a number which has got an I, definitely what should come in your mind is that this is a complex number. That's all. Something that doesn't, a number that doesn't have an I, it is a real number. So a real number is a number from negative infinity to positive infinity. Okay, so I can give an example. If I give you negative 2, maybe pi over 27, okay, the square root of 2, all these are real numbers. Okay, if I give you the square root of negative 4, but I'll come back to this, the square root of negative 4 and like. So now a complex number, an imaginary number is a number which has got an I. So I've told you to say, some people will say a plus bi, some will use x plus iy, like that. So you can say x plus iy or x plus yi. It's basically the same thing. Okay, but let's talk more about imaginary numbers. Okay, so let's assume to say we have got the square root of 4. So the square root of 4 is 2. So this is basically a real number. So now the square root of 4 is basically 2. But what if I ask you to say the square root of negative 4? If you punch this on your calculator right now, it's going to give you math error. It is definitely undefined. Okay, so we will just imagine to say, oh, okay, if I do 2 times 2 is 4. But now this is an imaginary. We are just imagining. It is undefined. It's not possible. We can't have the square root of negative 4. But if we come back to complex numbers, we're going to say, okay, so this is an imaginary number. So the square root of negative 4 is basically 2i. So the I tells me that this is an imaginary number. But before we go there, one thing I want you guys to understand is that if I have I squared, this is negative 1. But where does this negative 1 comes from? Okay, So if I want to make I as a subject of formula here, I can square root both sides. Then I will be the square root of -1. So this is where this thing is coming from when you hear to say -4, the square root of -4 is 2i. It's because I is equal to the square root of -1. Meaning that if I want to make I squared from here, I've told you that I squared is basically -1. So if I want to make I as a subject of formula, I is equal to -1. Meaning that any number, as long as it is in the square root and there is negative, I can find the square root of that number. Then I have to add the I. Meaning that that number is an imaginary number. It's not a real number. Okay? So if I give you I squared being equal to -1, what of I to the power 3? So if I give you I to the power 3, you definitely know that I to the power 3 is as a result of I squared and I. So then I know that I itself is -1 times I. So this is going to give me -I. So I want you guys to see the trend which is happening there. Okay? Basically, there's a formula which we can use, but I feel like it's just sheer waste of time. Because if I know that I squared is -1, then I don't have, I'm not going to have any problem on how to find anything involving I. So one thing we should understand is that anything, as long as we have got I squared, we can replace that with -1. Simple. So the square root of -1 is I. The square root of -4, it is 2i. So I tells me that there is what? There is, in the square root, there was a negative. It is an imaginary number. Okay, cool. So apart from knowing this, another thing that we have to know under complex number is we have just introduced I. Okay, so we are saying that I squared is equal to -1, and the I is basically the square root of -1. That's what we have said. So if I can give you I raised to the power 6, what would be the answer? What do you think the answer is going to be if I give you I to the power 6? Anyone who can try? I to the power 6. It can be written as same as what? Okay, so this can be written as I to the power 2 times I to the power 2 times I to the power 2. Of which I know that I to the power 2 is -1 times -1 times -1. Or -1 times -1 +1. +1 times -1, I'll end up having -1. So this is very important for us to know. Okay? But if you want to know the shortcut on how you can do this, there's a formula which I'm going to give you at the end of today's discussion, or maybe tomorrow. Maybe it will be easy for you. But one thing I want you guys to understand, that I to the power 6 is the same as I to the power 2 times I to the power 2 times I to the power 2. Okay? So now, apart from this, one thing I want you to understand is that you can only, when it comes for addition and subtraction, one thing I want you guys to understand is that you can only add, when you have got the combination, when you have got a complex number, you can only add the real number alone and the imaginary number alone. But when it comes for multiplication, yes, you can multiply a real number and an imaginary number. That is okay. But addition, you can only add real number and real number alone. For example, let's go to now question 1. It will be easy for us to understand better. So for example, this question was saying, that is the question 1 from tutorial sheet 1. They are saying perform the indicated operation, simplify and write the result in form of x and iy. So they are telling us to write the results in a form of x and iy, where x is a real number, iy is basically what? An imaginary number. And if you think of this thing is coming from an xy plane. If I have got an xy plane, I do know that this is my x, okay, this is my y. So this is what is happening here. So you always have this. So x is always the real number, then iy is basically what? In y-axis, that's where we're going to have the imaginary number. Okay, but I'm going to teach you more about this when we start talking about the polar form, okay, and the rectangular form. That's when I'm going to focus more on the xy plane. But for now, I want us just to do the introduction, okay, so that we have an idea of what a complex number is. So for example, if I want to perform the first one, so the first question, we have 3 minus 4i. Now in the brackets we have got plus -5 plus 7i. So we can clearly see here that it's okay, I can just open the brackets, it's fine, because it is we have got plus in between here, so it's not going to affect anything. I can open the brackets. So if I open the brackets, it's going to be 3 minus 4i. Now this plus times negative is still going to give me -5, then plus 7i. Like I said, when it comes for the addition and subtraction, I can only add the real number alone and the imaginary part alone. So here we can clearly see that I've got the real number here and the real number here, so they can be added. What is 3 minus 5? That is -2. Then these also can be added. What is -4i plus 7i? That is plus 3i. So I can clearly see that -2 is x and 3i is iy. So now I've written this in a form of x plus iy. Okay, so for the first question, this is the answer. Is that okay, guys? Let's try to interact. Is that okay? Okay, so if that is okay, then I want you to go ahead and also go ahead and solve part 2. So I'm not going to solve part 2, but I want you to go ahead and solve part 2. You can take a screenshot and then you are going to send me the answer after the class. But I'm interested in part 3. Let's go and do part 3. So part 3, we have 2 plus I, 3 minus 2 over 5, then we have got I. So this is now multiplication. I told you to say multiplication, you can multiply the imaginary and the real number. That is okay when it comes for multiplication, but you can't add the real number and the imaginary. It's not possible. So when it comes for the addition and subtraction, you can only add or subtract a real number to real number, imaginary number to imaginary number. But when it comes for multiplication, we can multiply them. So for example, here the way we are going to do it, we're going to say 2 times 3, which is 6. Or if you want, the simplest way is just to write 3 minus 2 over 5, I, then plus I, open brackets, 3 minus 2 over 5i, like that. Then you start now multiplying one by one. 2 times 3 is basically 6. Okay, minus 2 times 2 over 5, it is 4 over 5, I times 3, it is plus 3i. Then I times -2 over 5, it is -2 over 5 I squared. But one thing we should remember is that wherever we see I squared, we have to replace it with -1. We know what I squared is. Okay, so what I'm going to do now is I'm going to rewrite this and say this is the same as 6 minus 4 over 5 I plus 3i. Now here is going to be minus 2 over 5 times negative 1, because I squared is negative 1, of which this is the same as negative 1 times the negative which I have here. I'll end up having positive. So then I can write this the same as just here I put plus 2 over 5. As simple as that. Now from here I can add the real part and real part, imaginary and imaginary. Simple. So then what I'm going to do is I'm going to say what is 6 plus 2 over 5? The common denominator is 5. Here I'll end up having 1. So 1 into 5 is basically 5. 5 times 6 is 30. Then here I'll end up having 2. So it's 32. So I've added these two and I have 32. We also need to add 4 over 5 plus 3. Okay, so we need to add negative 4 over 5. I need to put I plus 3i. So here is same as I have got 1. So here the common denominator is 5. So I'll say 5 into 5 is 1. 1 times negative 4 is negative 4i. You can just mute your mic. Okay. So then I'll say 1 into 5 is 5. 5 times 3 is 15. So what is negative 4 plus this is negative 11. So then I'll end up having negative 11 over 5i. So now this is in a form of x plus I y. So the correct answer for this question is 32 minus 11 over 5i, like that. So I have written this in a form of x plus I y. Okay, so it's not something that is complicated. So now I want you again to go ahead based on the example which I've given you. I believe we can solve now this one. So go ahead and solve that other one. I'll also need the answer. But I want us to talk about division now. Okay, so there's an interesting part that we need to learn when we're talking about division. There's what we call a conjugate. So let's first learn about conjugate. So what is a conjugate? If I give you something, I think you learned when in semester 1 when we're talking about SADS. For example, if I have 2 plus the root of 3, the conjugate of this is 2 minus the root of 3. So you put the negative where there is a SAD when you have got when you are dealing with SADs. But when we are dealing with complex numbers, you change the sign where there is an imaginary part. For example, if we have got 3 plus 2i, the conjugate of this is 3 minus 2i. Okay, if I have 4 plus 7i, the conjugate of this is 4 minus 7i. What if I have got I've got I plus 2? What is the conjugate? So you put you change the sign where there is an imaginary. So now in this case, yes, you have got a question. So in this case, yes, Kelvin, you have got a question. So if you don't have a question, you can just mute your mic. Okay. So in this case, the imaginary is I. So we have to change the sign where there is I. If you have got a question, you can ask.
I'm not able to see, sir.
You're not able to see. So you can leave the meeting and then rejoin again.
Thank you, sir.
Sure. So in this case, the imaginary is I. So I have to change the sign that there is I. So then I can either say it's negative I plus 2, or I can say it's 2 minus I, which is the same thing. I've not changed anything. So that is the principle of the conjugate. So now, one thing I want you to understand is that whenever you are dealing with a division, we always conjugate the denominator and not the numerator. Okay? So for example, the first question which we have here, we want our expression to be in the form of x plus iy, but how can we make it? Then we have to, if we take the conjugate of the denominator is going to be cancelled out, and then we'll end up having x plus iy. Okay, so if I have got 1 plus 3i, I divide this by 3 plus I. So then the next thing that I have to do with this expression is I have to multiply by the conjugate both on the numerator and the denominator. So the conjugate of the denominator in this case is 3 minus I. Even here I'll do the same, 3 minus I. Then I can multiply now. So I'll say 1 times 3 is 3. 1 times negative I is negative I. 3 times 3 is positive 9i. Then negative 3 times, or positive 3i times negative I, it is negative 3i squared. Okay, I divide this by, I'll say 3 times 3 is 9. 3 times negative I is negative 3i. Then I times 3 is plus 3i. Then I times negative I is negative I squared. Now from here, one thing I have to remember is that whenever I see I squared, I have to replace it with negative 1. So then this is the same as 3, these two can be added, negative I plus 9 is plus 8i. Then this is going to give me now plus 3, because I squared has been replaced, so it's more like I have got negative 3 times negative 1, which is just positive 3. I divide this by this is going to give me 0. Again, 9 minus I squared is negative 1, like that. So then these two can be added. So this is going to give me 6. So I have 6 plus 8i. I divide that by, that is going to be plus now, which is going to end up, we're going to end up having 10. So to make things simple, again, we want this to be in a form of x plus iy, of which I can say is the same as 6 over 10 plus 8 over 10i. But again, there is a number which can go into 6 and 10. 2 there 3, 2 there 5. Then here 2 there 4, 2 there 5. So this is my final answer for part 5. Does that make sense? Based on this example, do you think you can solve part 6? This one. Do you think you can solve that one? Guys, let's interact. Do you think you can solve that other one? Okay, so what I'm going to request you is I want you to solve this question. You can solve this one. You send me the answer. Then let's go ahead and solve this one. Yes, please. Yes. Yes, I'm getting you. You can ask. Okay, let's now solve, but we solve this one. So this question is 3 minus I, 2 plus 3i. I divide it by 1 plus I. Okay. So then what we can do from here is I have first to make the numerator to be just the single, like the way the denominator is. So what I'm going to do, I have to multiply that. I have to make it simple. So I'll say 3 times 2, I'll end up having 6. Then 3 times 3, I'll end up having 9i. Then negative I times 2, I'll end up having negative 2i. Then negative 3i squared. I divide this by, this is not going to change for now. Then I know that 3i squared, I squared is negative 1. So then that can be 6 plus, these two can be added. Let me not put plus first. So 9 minus 2 is basically 7i. So this I'll end up having minus 3, then minus times negative 1, because I squared is negative 1. So we divide this by 1 minus or 1 plus I. So then we know that negative and negative will end up having positive. So we end up having 6 plus 7i plus 3. Then I divide this by 1 minus plus I. So then this is going to give me 6 plus 3. This is 3. Is 9 plus 7i. I divide that by 1 plus I. So when you reach at this point, then you have to multiply the top part and the down part by the conjugate of the denominator. So when I reach at this point, I'll say times the top part, the conjugate of 1 plus I, it is 1 minus I. Even here 1 minus I. So if I start now multiplying this, it will be 9 times 1. It will be 9 times 1, that is 9. 9 times negative I, that is negative 9i. Then 7i times 1 is 7i. Then 7i times negative I is 7i squared. I divide that by another principle that I can show you, but if you want, if you're going to get it, you can be using it. It's one of the quickest thing or simplest thing. If you're multiplying something by its conjugate, it's the same as squaring the part having negative. What do I mean? For example, yes, you can ask. Brenda, I can't get you. I think I don't know if it's your network.
Saying 3 times 3i, isn't it not supposed to be negative 9i?
Which one are you talking about?
For the second, for the first one, the one underneath the thingy, the tutorial sheet, you've written to say 6 plus 9i minus 2i minus 3i squared. Is it not supposed to be 6 plus 9? Oh no, 6 minus 9i minus 2i minus 3i squared.
Okay, you mean this one?
Yes, that one, yes.
Okay, let's redo it.
Tell you when you multiply 3
With,
by negative 3i, it's going to give us negative 3i.
okay, let's do it again. We said 3 times 2, we got 6, right?
6, yes.
Then 3 times 3, we got is 3 times 3, we got 9i, right?
The other 3 is negative. It's negative 3i.
No,
Or
it's
I just haven't seen
no,
properly.
you haven't seen proper. It's positive.
No, so it's negative. Oh yeah, it's positive.
No,
Thank you.
it's positive. Yes,
Yes. That's all. Thank you.
sure. So now, what is happening here now is this. I want to show you the quickest way on how you can multiply anything by its, as long as you get the conjugate of that numbers which you have. So for example, if we have 1 plus I, the conjugate of this is 1 minus I. So when you are multiplying this, instead of you wasting time, because there is no mark for you multiplying this, it's the same as squaring the part having negative. So the part having negative, in this case, it is this one. So if I square 1 squared, then I also square I. So the negative, don't square the negative for you to get positive. Just leave the negative, square the numbers independent. So then it's going to be 1 minus I squared. And for sure, if I multiply this and this, I'll end up having 1 minus I squared. Let's do it. 1 times 1 is 1. 1 times I is I. I times 1 is plus I. Then I times negative I is negative I squared. So now we also know that this is negative 7I squared. Where there is I squared, replace it with negative 1. Then we end up having positive 7 now. So it will be 9. If I add negative 9 plus 7, I'll end up having 2I. Okay, I lost my connection, but I'm back. Okay, so I was showing you that this is going to give me plus 7. We know that. Then down here, I know that these guys will give me 0, so I'll end up having 1 minus I squared, which is the same as this one. So if you're multiplying anything by its conjugate, square the part having negative. Simple. Then you are home and dry. That's the easiest way. Okay? So now, I have now 9 plus 7 is 16. And then down part there, I already know that, so I have 9 plus 7, that is 16. I can write 16 here. Then minus 2I. But down here, I've got 1 minus, then there's also negative 1, of which I'm going to have 16 minus 2I. I divide that by 1 plus 1, because negative and negative, I'll end up having 1 plus 1. So then I'll have 16 plus or minus 2I. I divide that by 2, of which my final answer will be 16 over 2 minus 2I over 2. Then the final answer will be 16. 2 into 16 is 8. Then 2 into 2 is 1, so which is just I. So this is the final answer. So the answer is supposed to be in a form of I plus IY, which is what I have here. So I don't think you can have problems with even solving this question here. I want you to choose which one should I solve for you between this one and that one. Then one of these you are going to solve yourself. So this one you are going to solve again, you are going to send me the answer. So I want you to solve, I want you to help me with solving this. I've given you this question to solve that one. You also solve this one. You also solve this one. Then you also solve this one. But now I want you to choose which one do you want me to solve for you between this question and this one. You can choose between 9 and 10. Which one should I solve for you? Yes, please. Solve 9. But don't you think that 9 is the simplest one than 10? Anyway, let's solve 9. So if I solve 9, you'll be able to solve 10, right? Not so, guys. Yes, please. Yes, I'm getting you.
I think solve number 10.
Number 10. Okay. How many people are saying we should solve number 9? Okay. Okay. Okay, let's solve both if we have time. Let's start with the first one. So the first one is just the matter of us opening the brackets. So if I open the brackets there, then I'm going to have 5 minus 4i. So negative is going to affect what is in the bracket. So negative and positive, it will be 3, then minus 7i. Then down here we have 4 plus 2i plus 2 minus 3i. And this we know that we have now 5 minus 3, that is 2. Negative 4 minus 7 is negative 11i. Then I divide this by 4 plus 2 is 6. Then 2 minus 3 is negative I. From here, I believe you can't fail. Not so. So that we solve 10. From here, can you fail to finish it up? Okay, so you can finish from here. I think that was the difficult part, maybe simplifying from this form to that form. Because this one is basically the same as the one we were solving here. So let's go ahead and solve 10 because of time. So I want you to go and finish this one. You can just screenshot this, take a screenshot, and then finish it up. Then you'll be able to send the answer. So let's go ahead and solve question 10 quickly. So question 10, we have 4 plus 5i plus 2i squared. Even if I open the bracket, there's no different there. So I squared, in fact, to make things simple, I squared is basically the same as times negative 1. So it's the same as minus 2. Then I divide this by, allow me to expand this, because that is going to be the same as this. So 2 times 2 is 4. 2 times I is 2i. I times 2 is 2i. Then I times I squared. So then it will be 4. 2 plus 2 is 4i. Then this is going to be minus 1. So I'll end up having 3 minus 1. 3 minus, no, not 3 minus 1. 3 plus 4i. So down here now I've got 3 plus 4i. I've simplified it. So then if I see here, I can say 4 minus 2 is basically 2. 5i. Then down here I've got this 4i. Now when I reach at this point, I don't think we have got problem here. Don't you think you can finish from here? Isn't it the same with the questions we have been solving so far? It's the same. So now what I want you guys to do is finish this and finish that one. So if you have time, if you can manage to solve them today, but most important thing, I want you to send me the answer for this question. Then you can also finish it up, this one. then you send me the answer. So the answers I want you to find to send me is this question here and this question. But the rest you can solve, but I'm going to send you the answers so that you compare with the answers I found. Okay? But the answers I want you to send me is for part 8 and the part 10, which we have just listed here. So you continue from there. I hope you have got no questions, but if you have got questions, you can still ask. So this tutorial sheet, the good part with it is I think I last time I yes, please, you can ask. Yes, guys, you can ask if I've got a question. So this tutorial sheet, I showed you this tutorial sheet. The questions are a lot. Like it's a full topic. So what I did was um I managed to solve this tutorial sheet. So if you are one of those guys who are registered with us, then you'll be able to access this one. So if you go on complex numbers, which is here in math, I solved. So what I did, I explained everything on complex number, and again I solved the tutorial sheet. So if you see this question 1, I solved this question 1. So you'll be able to find even those other questions we have not solved. They are here. So now it's better if you can just register with us, then you'll be able to access these things. We have the tutorial sheet question from question 1 up to the last question. So in semester 2 for math, most of the times you are going to do only 2 topics: complex numbers and calculus. So calculus is broad. Actually, don't even do everything on calculus. So you do complex number, that will be the first one. Then you go to calculus. You start with limits, differentiation, integration, application of integration. Done with semester 2. And the good part is we have everything. We solved even some past papers actually. Okay, so this is what I had for you guys today. Have a blessed night. Unless if I've got questions, you can get in touch with me, and I believe you have my number. The number is there in the group. Thank you.